So this module is the Quick Start module. In this module, what we're going to be doing is we're going to be creating a basic NodeBot development environment. And this is intended for use on a Mac OS computer. There's another video if you're programming in a Windows environment. So there's a bunch of different ingredients that are going to go into this project. Some software prerequisites. In addition to our operating system, we're going to need Xcode and Xcode command line tools, which we can check right now. This is just needed for kind of utilities. So if you go to a command line and you just type make, for example, if it gives you an error like this, that means make is functional. This is the expected error. It might direct you to go install Xcode or accept a end user license agreement. Just jump through those hoops. Next, we're going to need the Arduino IDE, which has not been indexed yet. And we're going to need this for installing Firmata on our Arduino device. So go ahead and download that, which you can find on their website. Download for your platform and install it. When it's installed, it should look something like this when it's functional. Then we're going to need some physical things. So coming over to the camera view, you're going to need, in this case, an Arduino Uno or equivalent clone compatible board. I'm using an Adafruit Metro here. You need a tiny breadboard, or a big breadboard will work too. You're going to need some wires to hook some stuff up. And we're going to use a button and a light emitting diode to verify that our software environment is functional and that we can push code that runs and stuff on our Arduino. So let's go ahead and get going. The first step we're going to do is we're going to install Firmata on our Arduino. Firmata is a special protocol that allows us to communicate with all of the pins and electronics connected to our Arduino from code that is running on our workstation. Or in the case of an independent disconnected device, it might be running on something like a Raspberry Pi. Let's go ahead and we're going to plug in our Arduino so that we can program it. And the Firmata program actually the sketch comes with the Arduino IDE. You'll find it under Examples, Firmata. And standard Firmata is going to be sufficient for our project. Let's go ahead. It's a nice program. You can read it if you want. It's actually very understandable. But we're just going to go ahead and upload it to our board. So Sketch is going to compile, and it's going to upload. And it's done. And now we can close the Arduino IDE, and we don't need to touch that again for the rest of this project. So next, let's go back over to our workstation. We'll open up a terminal and install Node.js if you do not already have it. So I am using version 8.9.4, which is the current long-term support. That's fine. You can also use version 9 if you prefer. But you can go ahead and download it. The easiest way to download a Mac is to just download it from nodejs.org and download the installer. It seems to work better than trying to install it from Brew or a package manager or something. Next, we're going to make a directory for our project. Already did. Then we need a package.json file. I'm just going to delete mine. And the lock file. Hear it all? Yeah. Then what we want to do is we want to initialize our project so that we have a place to store all of the dependencies we're going to be using and other metadata about our project. So if you just do npm init, it'll take you through a little step-by-step. We're going to go ahead and select most of these defaults. I'm going to use a different license, but you can use any license you like. We're going to go ahead and do that, and this created a package.json file, which contains all the stuff we entered in that little step-by-step interactive creator. We've initialized our project. Next, we're going to install Johnny5 as a dependency on the project. Johnny5 is a really awesome library for writing JavaScript that interacts with electronics over Firmata. So go ahead and install it and tell it to save the dependency. And add it to our package.json. You can see Johnny5 in there now. Oh, we added Firebase admin. Ignore that part. So next, we're going to do a little bit of electronics work. We're going to go find a simple thing to implement with Johnny5 just to verify that our software environment is working properly. We're going to unplug our board because we're going to be doing some electronics work, and you should unplug it before you work on it in general. Then my favorite way to work with Johnny5 is actually from the examples. We're going to go on into the examples and we're going to find button. We're going to get the simplest button example. And there's a picture here of a circuit. And we are going to make our breadboard and Arduino look basically like this. So let's go ahead and dive in. The first thing you see the example do is copy like 5 volt and ground to these side rails. This tiny breadboard we're working with does not have those. So we're just going to copy it to the top rows of our board. I'm going to use green for ground. And copy that over to the top row. Then we're going to take the 5 volt line. We're going to copy that to my little pin, and my thing is starting to wear out. Get one with slightly longer leads. Go to the 5 volt pin, and we'll copy that somewhere else. So I'll copy it like a couple lines below on the breadboard. Let's reduce the chance that they kind of cross paths and short out, because that would be sad. If they touch, things will stop working. The next thing in this picture is the button. We're going to go ahead and take a little push button. We're going to push it onto our board, not in the same rows that we just used above. And then we're going to use a little wire to connect our voltage to the top of the button. So this will make it so the top of the button is always on, essentially. Then we want to read the button when it's pressed down. I'm going to get another wire, and I'm going to connect the bottom of the button to pin 2. Way down there, I need a longer wire. Use one of these long green ones. So we're going to connect the bottom of the button . We're connecting this to pin 2. Down those wires so this thing stays relatively in place. Great. Okay, so now the bottom of the button goes to pin 2. But there's one other thing you'll notice here. There is a resistor. It is a 10 kilo ohm resistor that is connected between the sense pin, the side of the button that is going to our digital input, and ground. And the reason for that is if you didn't have this, when you let go of the button, there would be some charge trapped in here, some electrons trapped in here, and they would trickle through this read pin, and it would kind of flutter on and off, and it might take a second to return to off. It would take a while for it to get there. So what we need some way to drain stuff out, like a terrible wire, in this case a 10 kilo ohm resistor. So we're going to take that, and we're going to squish that in here, and we're going to cover up a big part of our circuit. And connect to ground. There, so that's done. You can kind of see it's not all covered up, only partially. But essentially I've connected my green wire, which went to ground, and I'm connected that to here. So in the case where the button's being pressed down, the terrible wire is not going to do anything, and we will be able to read on pin 2 that there's a high. The button is down. When we let go, the terrible wire will take over and drain any excess charge from that circuit. Now we've copied the physical diagram. Let's scroll down and we see code. This is my favorite part about Johnny 5 is this code goes with that diagram. So let me make a new index. And anyway, because I had some other code open. We're going to paste that code in. And let me see, did it actually paste? There it goes. So paste that code in and get rid of a bunch of stuff we don't actually need. We'll leave REPL in. This is for being able to interact with your electronics from the command line, which is useful. I'll just delete some comments so it fits better on the screen. We don't need the hold, we just want up and down. So we have a very short program where we initialize Johnny 5, create a board. When the board is ready to go, we create a button, and then we respond to up and down events on that button. So this is a good way to verify that our stuff is working. Let's plug in our board and run our program. It was able to connect to the board and it is on. So when we hit the button down, it says down on our console. When we let go, it says up. It's working great. But we have this LED not doing anything. So let me take this opportunity to show you a little bit about another reason Johnny 5 is awesome. All of these different examples are composable. So we can go right on up to the LED example. And we can see there's an LED that's connected between ground and pin 13. So we can unplug our device. Boop. And we can just copy that straight ahead. The longer pin, so LEDs actually have a long pin and a short pin. Oops, let me get that on camera. They have a long pin and a short pin. And the longer pin needs to go to a voltage source and the short pin needs to go to ground. So let's go ahead and do that on our board. So we could just jam it in there like they have, or we could do it on our breadboard. Let's be tidy and do it on our breadboard. We have the longer pin towards the top. So I'll put that in and bend it over, and then we will copy some signals around. So we'll copy the ground signal. Actually, I'm going to flip it over so that the long pin is on the bottom. And I'll put it over, I guess over here. So I'm going to copy ground to the short pin. I'm going to use another longer wire. Let me adjust some things so I can kind of tuck it in there. I'm removing this pull down resistor up a little bit. Then I'm going to plug this into ground. And then we'll copy that to the short pin, which was the top one. So we'll put that in the same row. And then we'll connect the other pin to our digital. In this case, we're going to be using pin 13 as a digital output. Although pin 13 is actually a little special, it flickers when other events happen on the board. So I'm actually going to be crazy and switch it to pin 12. Get a shorter wire so it is easier for you to see. Let's get one of these yellow ones. We're going to connect pin 12 to the longer pin of the light emitting diode. Then we can go down and copy this code. So we need to create an LED. Go back to our code. We can paste an LED in right below our button. We can add our LED to our REPL. And then when the button goes down, we can turn the LED on. When the button goes up, we can turn the LED off. Oh, but this is still set to 13. We change it to pin 12, so we change it to 12 in the code. We can go ahead and run our program. It does not find our board because it's not plugged in. So we will plug in our board and then run our program. REPL is initialized, and when we press the button, it sees it, but it doesn't do much. Let's do some quick troubleshooting. Let's turn the LED on when we first run our program. Not turning on. What we can certainly do is pull out this implementation, unplug our board, and just basically do what's in that picture up there. 12 to ground. Now it looks a lot like what we had up there before. And that's just kind of like, because for a lot of these things, you end up having to kind of like futz around with wires a little bit. Make sure you get it in everything happy. Oh, I may have destroyed this LED. That would explain. So the LEDs I have here are pretty good at handling a wide range of voltages. They change color, like they go through a little pre-programmed color cycle. But one of the reasons I use them is that they handle a variety of voltages. I think they go up to like 9 volts without a problem. Let's go ahead and try running that again. Oh, there we go. It was definitely the LED. Except backwards. That little debugging code I left in there. There it goes. Now it's behaving properly. It's because the debugging code I left in there was still running. So great. So this gives us a pretty simple circuit. We have an LED with a pull-down resistor and a button, and we have a running Johnny 5 environment. We verified that everything functions, and then we can use this as a foundation for the rest of our hacking and the other modules for this lesson. So go ahead and select the next thing you want to work with.